NASA has the best images ever taken of an interstellar object. Images captured 8 days ago by a camera that can resolve details as small as 30 kilometers per pixel. Images that could tell us definitively what this 3.5-mile-wide visitor from another star system actually is. And they're not releasing them.
However, the principal investigator of that camera said that he cannot communicate the information to the public because of the government shutdown. Now, that of course raises some concerns that maybe they know something and do not want to let us know about it. And my interpretation is that it's probably not flagging extraterrestrial intelligence. It most likely is the result of terrestrial stupidity.
Here's what I don't buy the shutdown excuse either, but not for the reason you think. If you've been following the story of 3I Atlas, you've seen the clickbait, the speculation, the wild theories, and somewhere buried beneath all that noise is something genuinely fascinating that nobody's talking about properly. Because the real story of 3I Atlas isn't about whether it's an alien spacecraft. The real story is about how we do science when we encounter something we don't fully understand yet. I'm going to tell you exactly what we know about this object. Not what we suspect, not what sells headlines, what we have actually proven with telescopes, spacecraft, and peer-reviewed scientific papers. And along the way, I'm going to show you why the controversy around Harvard astrophysicist Avi Loeb reveals more about how science works than about this comet itself. By the end of this video, you'll understand 3 things. First, what makes 3I Atlas genuinely unusual based on verified measurements? Second, why the scientific establishment's treatment of Avi Loeb is more problematic than his actual methodology. And third, how a global network of amateur astronomers is doing better science than some professionals by simply looking at the data without prejudice. But we need to start with what happened on October 2nd. Because that's when the narrative about this object started to fall apart. And I mean that in a good way. On July 1st, 2025, a telescope in Chile detected something moving. Not just moving, but moving wrong. The Asteroid Terrestrial Impact Last Alert System, ATLAS for short, flagged an object with a trajectory that didn't make sense for anything born in our solar system. When astronomers traced its path backward, they found something surprised, remarkable. This object didn't orbit the sun, it was passing through. One time, never to return. Its orbital eccentricity measured at 6.141. To put that in perspective, anything above 1 means the object is not gravitationally bound to our star. The first interstellar visitor, Oumuamua, had an eccentricity of 1.2. The second, Comet Borisov, came in at 3.6. As you can see here on this graphic, with eccentricities of 1.2 and 3.6, Oumuamua and Comet Borisov are moving so fast that the sun's gravity is insufficient to capture them. 3I Atlas 6.1. It's the most hyperbolic trajectory we've ever measured on an interstellar object. This thing is in a hurry to leave. Now here's where things get interesting. Within days, telescopes around the world trained their instruments on this visitor, and what they found challenged some early assumptions. Initial brightness measurements suggested this could be a monster, potentially 20 kilometers across. That would make it dramatically larger than the previous 2 interstellar visitors. But then, Hubble looked. And Hubble doesn't lie. On July 21st, the Hubble Space Telescope captured the sharpest image yet of 3I Atlas when the object was 226 million miles from Earth. The image revealed something crucial: a teardrop-shaped coma of dust and gas surrounding a nucleus. This wasn't just a rock, it was active. It was a comet, and Hubble gave us hard numbers. The diameter of the nucleus is somewhere between 0.32 kilometers and 5.6 kilometers. Most likely, less than 1 kilometer across. Not 20, less than 1. This is important, and we'll come back to why. But first, let me tell you what makes this object genuinely weird. And I'm not talking about speculation. I'm talking about measurements that made scientists scratch their heads. On August 6, 2025, the James Webb Space Telescope aimed its near-infrared spectrograph at 3I Atlas can do something Hubble can't. It can break down the light from an object into its component wavelengths and tell us exactly what chemicals are present. When the data came back, it revealed something that had never been seen before in a comet at this distance from the Sun. The coma surrounding 3I Atlas is dominated by carbon dioxide, not water, carbon dioxide. The ratio of CO2 to water measured at 7.6 to 1. To understand how unusual this is, you need to know that this ratio is 4.5 standard deviations above the trend line for all observed long-period and Jupiter family comets. In plain English, this is statistically anomalous. JWST also detected water vapor, carbon monoxide, carbonyl sulfide, and water ice. But carbon dioxide is running the show. Most comets in our solar system are dominated by water ice. When they approach the Sun, water sublimates and creates the characteristic bright coma and tail we associate with comets. But 3I Atlas behaves differently. Carbon dioxide sublimates at lower temperatures than water, which explains why this object showed activity as early as May 7, 2025, when it was still 6.4 astronomical units away from the Sun. That's beyond Jupiter's orbit. The JWST team published their findings in a peer-reviewed paper. Their conclusion? This composition suggests that 3I Atlas either formed far from its parent star, beyond the carbon dioxide frost line, where temperatures are cold enough for CO2 to condense into solid ice, or its ices were exposed to higher levels of radiation than typical solar system comets. But JWST wasn't done. In late August, the Very Large Telescope in Chile detected something else: cyanide gas and atomic nickel vapor, at concentrations similar to what we see in solar system comets. So 3I Atlas has both familiar and unfamiliar chemistry. Now let me tell you how old this thing is. Avi Loeb and his colleague Shokruz Kakarov traced the galactic trajectory of 3I Atlas backward through time. When you account for its speed and the vertical excursion from the galactic disk, you can estimate age. Their calculation: 3 to 11 billion years old. For comparison, Oumuamua appears to be about 1 billion years old. Borisov around 1.7 billion years. 3I Atlas is ancient. It may be older than our entire solar system. Here's something else that's genuinely unusual: the trajectory. 3I Atlas's orbital plane is inclined just 5 degrees relative to the ecliptic, the plane where Earth and the other planets orbit the Sun. For an object arriving from interstellar space, from a random direction in the galaxy, the probability of being aligned this closely with the ecliptic is about 0.2%. 1 in 500. But it gets better. On October 3rd, it passed within 29 million kilometers of Mars. On November 3rd, it will pass within 97 million kilometers of Venus. On March 16th, 2026, it will pass within 54 million kilometers of Jupiter. The timing of these encounters, arriving at each planet's orbital radius when that planet happens to be nearby, the probability is about 0.0005%, 1 in 20,000. Combine those two independent probabilities, and you get a likelihood of less than 1 in a million that this trajectory and timing occurred by random chance. Now, before you jump to conclusions, let me be very clear. Low probability does not equal impossible. It means rare, and rare things happen. The question is whether this statistical rarity combined with the unusual chemistry adds up to something worth investigating with an open mind. And that brings us to the scientist who has become the lightning rod for this entire debate. Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University, former chair of Harvard's Astronomy Department, founding director of the Black Hole Initiative, author of hundreds of peer-reviewed papers. By any measure, he is a serious scientist. He is also the most criticized astrophysicist in the field right now. And here's what nobody wants to admit. Most of the criticism is not about his data. It's about his willingness to consider hypotheses that make people uncomfortable. Let me show you what Loeb actually said about 3I Atlas. He created something called the Loeb scale, a 0 to 10 ranking system for interstellar objects. 0 means definitely natural. 10 means confirmed technology on a collision course with Earth. Where did Loeb rank 3I Atlas? Between 4 and 6, depending on which of his essays you read. Later, he stated a 30 to 40% likelihood that it does not have a fully natural origin. In his own paper, co-authored with Adam Hibbard and Adam Crowell, Loeb wrote, "By far, the most likely outcome will be that 3I Atlas is a completely natural interstellar object, probably a comet, and we await the astronomical data to support this likely origin." You get all the link on description to take a look on the source of my information. Read that again. Most likely outcome is that it's natural. He is explicitly stating the null hypothesis. So why is he being portrayed as claiming it's definitely alien technology? Because media outlets take his "we should investigate the possibility" and turn it into "Harvard scientist says alien spacecraft." But those are not the same statement. One is scientific methodology, the other is clickbait. Now, Penn State astronomer Jason Wright has publicly criticized Loeb's analysis in a series of blog posts. Wright points out specific technical errors in Loeb's reasoning. For example, Loeb initially focused on early brightness estimates suggesting a 20-kilometer nucleus and called this rarer than it looks, implying the large size made a natural explanation unlikely. But as Wright correctly notes, those early estimates were measuring the coma, not the nucleus. Hubble later showed the nucleus is much smaller, likely under 1 kilometer. Wright also criticized Loeb for dismissing the extended coma visible in images, claiming it might be due to telescope tracking errors. As Wright points out, this is basic astronomy solved a century ago. Observers routinely track moving objects. The extended coma is real. These are legitimate criticisms of Loeb's analysis. Wright is correct on these technical points. But here's where it gets interesting. Jason Wright himself co-authored a paper about searching for technosignatures from interstellar objects. In that paper, which included expertise from the planetary science community, Wright and his colleagues wrote, "The presence of normal behavior, such as natural cometary activity or surface colors consistent with bare asteroids, should not deter our follow-up observations aimed at constraining technosignatures." So Wright agrees that we should search for potential artificial origins even when objects show natural characteristics. The disagreement isn't about whether to look. It's about how Loeb is communicating his analysis and how he's handling data that contradicts his early assumptions. Here's what's actually happening. Loeb is practicing what's called inference to the best explanation. When you have multiple anomalies, unusual composition, rare trajectory, specific timing, you generate hypotheses that could explain them. Natural hypotheses come first. Ancient comet with unusual formation history, composition reflecting high radiation exposure, gravitational perturbations creating the trajectory, all valid. But Loeb adds one more hypothesis to the list, artificial origin, and he argues we shouldn't eliminate it without evidence. The mainstream response has been essentially, stop adding that hypothesis. It's so unlikely that we shouldn't waste time on it. But Loeb counters with a philosophical point. If you never add the hypothesis to your list, you'll never gather data that could support or refute it. You'll miss it if it's real. And he has history on his side. In 1794, German physicist Ernst Florenz Chladni was the first to publish the idea that meteorites might originate from outer space rather than Earth. The scientific community responded with mockery. The French Academy of Sciences dismissed the idea as impossible. It took decades and the dramatic Posidonia meteorite fall of 1803 before the scientific establishment accepted that rocks do indeed fall from space. Alfred Wegener proposed continental drift in 1912. He was ridiculed. Plate tectonics wasn't accepted until the 1960s. Barry Marshall suggested bacteria caused stomach ulcers in 1982. He was told it was impossible. He won the Nobel Prize in 2005. The pattern is clear. When someone proposes a hypothesis that challenges fundamental assumptions, the initial reaction is often rejection based on disbelief rather than data. Now, most challenges to conventional wisdom are wrong. That's fine. That's how science works. You test ideas and most fail, but some don't. And you can't discover which ones don't fail if you refuse to test them. Loeb wrote something in one of his essays that captures this perfectly. He said, quote, "Scientists change their opinions as they learn from new results." For example, Stephen Hawking wished to prove that the idea of black hole entropy, first proposed by the Princeton PhD student Jacob Bekenstein, was nonsense. When he did the quantum mechanical calculation, he realized that Bekenstein was right and black holes evaporate by emitting thermal radiation. This was the biggest theoretical discovery in Hawking's scientific career. So here's what I think is actually happening with the Avi Loeb controversy. Loeb is practicing a form of scientific inquiry that makes his peers uncomfortable because it forces them to confront their own cognitive biases. He's holding up a mirror and asking, are you rejecting this hypothesis because the data rules it out, or because the idea makes you uncomfortable? And the honest answer, for many scientists, is the latter. They haven't collected sufficient data to rule it out. They're dismissing it a priori because the prior probability seems vanishingly small. But as Loeb points out, prior probabilities are subjective. They depend on assumptions. And when you're dealing with something as profound as potential evidence of extraterrestrial technology, maybe, just maybe, we should gather more data before being so confident in our priors. Which brings us to the people who are actually doing this. The ones gathering data without the baggage of academic politics or tenure considerations. The citizen scientists. While professionals debate methodology on blog posts, there's a quiet revolution happening in backyards around the world. A global network of amateur astronomers is tracking 3I Atlas with a level of coordination and enthusiasm that puts many professional observatories to shame. Ariel Grajkowski, a postdoctoral fellow at the SETI Institute, coordinates the Unistellar community of telescope observers. This is a network of citizen scientists using network telescopes that allow detailed observations at a relatively low cost. A few $1,000s buys you a telescope that can contribute real data to real science. And they're seeing things. Strange things. Grajkowski told Supercluster, "It's getting more and more active and we're not seeing H2O yet," which is strange, but we are seeing a lot of other stuff. In late August, NASA's SPHEREX Space Observatory spotted abundant carbon dioxide in the comet's coma. But the water signature remained muted. This matches what JWST found and confirms what the Unistellar observers were noticing. 3I Atlas is not behaving like a typical comet. It's releasing the wrong volatiles in the wrong proportions. I want you to meet some of these observers. Wataru Ono from Japan initially joined to contribute to planetary defense research. He told Supercluster, I've since become interested in other programs as well, including comets. I believe one of the charms of this citizen science program is this personal domino effect where one thing sparks interest in something else. Margaret Luce from New Mexico said, "I really like having specific tasks to do. I like seeing the results come in, and I really like the international collaboration. These aren't hobbyists playing at science. They're contributing real observations that complement and sometimes exceed what professionals can do. Why? Because they have flexibility. Professional observatories operate on rigid schedules. If clouds roll in during your allocated telescope time, you lose that data. Citizen scientists can adapt. If there's a gap in coverage in one time zone, observers in another time zone step in. And there are other initiatives. Shadow the Scientists, based at UC Santa Cruz, hosts regular live streams on professional telescopes, letting anyone watch 3i Atlas in real time. The Zooniverse website has 3i Atlas photos on its Rubin Comet Chasers project, where volunteers help parse images from the Vera C. Rubin Observatory. The quality of some citizen science observations rivals professional work. Astrophotographer Efrain Morales has captured stunning images that clearly show the developing coma structure. These aren't just pretty pictures. They're scientifically valuable data points that help track how the comet's activity evolves as it approaches the sun. But there's something else happening here that matters beyond the data. Margaret Luce said something profound about 3i Atlas. She said, "It's never going to happen again. Our species will never see this object again." That's the real story of 3i Atlas. Not whether it's natural or artificial, not whether Avi Loeb is right or wrong. The story is that when faced with something we don't understand, humanity's response can be wonder, collaboration, a shared desire to know. But we still have unanswered questions, and one of them involves a delay that seems suspicious but probably isn't.
You think, I don't buy the shutdown excuse. That to me is really suspicious 8 days later that NASA hasn't released these photos. It's not like nobody is at NASA right now is able to do this. We did get one report that as 3i Atlas gets closer now to the sun, telescopes here on Earth are picking up other objects flying alongside it. Is that accurate?
Well, there are always objects. The question is whether we see unusual activity. And in fact, I tasked my research team at the Galileo project to monitor the sky for any unusual activity, because it's possible that if it's a alien probe, that in fact it would release some mini probes that will visit the planets.
Yeah.
You know, we should not assume anything. It's a blind date, and we should watch the other side, you know, just in case there is a serial killer there.
Remember how we started? NASA's Mars Reconnaissance Orbiter captured high-resolution images of 3i Atlas on October 2nd using the HiRISE camera. This camera has an angular resolution that translated to 30 kilometers per pixel at the distance of 3i Atlas from Mars. That's the highest resolution we'll ever get of this object. 1 pixel represents 30 kilometers of surface detail. And here we are, days later, and those images haven't been released. The official explanation? Government shutdown. The principal investigator can't release the data. Avi Loeb publicly stated he doesn't buy the shutdown excuse. He suggested it raises concerns that maybe NASA knows something and doesn't want the public to know. Meanwhile, the European Space Agency had no problem releasing data from their ExoMars Trace Gas Orbiter and Mars Express spacecraft. Both captured images of 3i Atlas around the same time. Lower resolution than HiRISE, but they got the data out. Here's what I think is actually happening, and it's both more boring and more frustrating than a conspiracy. High-rise data doesn't just download from the spacecraft and appear on a website. It goes through a processing pipeline. Raw images need calibration. They need geometric correction. Someone needs to verify the pointing data is correct. Someone needs to check for artifacts. This takes time. More importantly, it takes people. And during a government shutdown, many of those people are furloughed. The European Space Agency isn't subject to US government shutdowns. Their teams kept working, so they got their data out first. It's not a conspiracy. It's bureaucracy intersecting with bad timing. But here's the frustrating part. This delay didn't have to happen. If there had been a pre-positioned protocol for releasing high-priority interstellar object data during shutdowns, we'd have those images by now. If someone had thought about this scenario in advance and designated high-rise observations of interstellar objects as accepted activities that continue during shutdowns, we wouldn't be having this conversation. So when Loeb says this doesn't indicate extraterrestrial intelligence, but rather terrestrial stupidity, he's right. Just not in the way conspiracy theorists want him to be right. The stupidity is that we built a multi-billion-dollar infrastructure for observing the solar system, but didn't plan for edge cases like interstellar visitors during government shutdowns. When those high-rise images do get released, here's what they'll show us. If the brightest pixel in the image is significantly brighter than surrounding pixels, we can use that to constrain the surface properties of 3I/ATLAS. A smooth, reflective surface would create a different brightness profile than a rough, porous surface. If the object is rotating and we can see variations in brightness, we might detect the rotation period. What the images won't show is anything like detailed surface features at spacecraft resolution scales. 30 kilometers per pixel means if 3I Atlas has a nucleus 1 kilometer across, it will appear as maybe 30 to 40 pixels total. That's enough to see overall shape, but not enough to see, say, individual surface structures. So no, the delay probably isn't hiding evidence of alien technology. But yes, it's indicative of a larger problem. We're not ready for interstellar objects. We don't have dedicated missions to intercept them. We don't have protocols for rapid data release. We don't have international frameworks for coordinating observations. Let's pull back and talk about what 3I Atlas teaches us. Not about comets, about science. The controversy around this object reveals a tension at the heart of how we pursue knowledge. On one side, you have the conservative approach. Stick to explanations consistent with known physics. Don't invoke exotic hypotheses without extraordinary evidence. This approach has served science well. It prevents us from jumping to conclusions. It maintains rigor. On the other side, you have the exploratory approach. When you encounter anomalies, generate multiple hypotheses, including unconventional ones, and design observations to test them. This approach has also served science well. It's how we discover new phenomena. It's how paradigm shifts happen. The problem is that both sides think they're doing science correctly, and the other side is doing it wrong. But they're both right. Science needs both approaches. We need people who maintain high standards of evidence before accepting extraordinary claims. And we need people who are willing to ask uncomfortable questions and push boundaries. Avi Loeb and Jason Wright are both doing valuable work. Wright is correct to point out technical errors in Loeb's analysis. That's how science self-corrects. Loeb is correct to push for investigation of low-probability hypotheses. That's how science makes discoveries. The conflict between them? That's not a bug. That's a feature. Science advances through disagreement, through criticism, through testing ideas against data. So, what do we actually know about 3I Atlas? Let me summarize the verified facts. It's an interstellar comet with a nucleus likely less than 1 kilometer in diameter. it has the most hyperbolic trajectory of any interstellar object we've observed. Its coma is unusually rich in carbon dioxide relative to water. It contains cyanide and nickel in concentrations similar to solar system comets. It's between 3 and 11 billion years old. Its trajectory is unusually aligned with the ecliptic plane. Its timing for planetary encounters is statistically rare. All of these facts are consistent with a natural explanation. An ancient comet from another star system with an unusual formation history and rare gravitational interactions. That's the most likely explanation. But most likely is not the same as certain. And that small window of uncertainty? That's where science happens. The Vera Rubin Observatory will begin operations soon. It will detect dozens of interstellar objects every year. Most will be unremarkable, but some might be genuinely anomalous. When that happens, we need to be ready. Ready with observation protocols. Ready with international cooperation frameworks. Ready with open-minded investigation of all possibilities. And we need to empower citizen scientists, because they're proving something important. You don't need a PhD to contribute to our understanding of the universe. You need curiosity, dedication, and a willingness to point a telescope at something interesting. 3I Atlas will reach its closest approach to the Sun on October 29, 2025. Then it will begin its long journey back into interstellar space. In December, it will pass closest to Earth. In March 2026, it will fly by Jupiter. After that, it will leave our solar system forever. In a few decades, it will be beyond the orbit of Pluto. In a century, it will be multiple light years away, heading toward whatever corner of the galaxy spawned it billions of years ago. We got to see it for just a few months. A cosmic messenger delivering information about conditions in a planetary system we will never visit. Information encoded in its chemistry, its trajectory, its age. And whether it turns out to be a completely natural comet or something more exotic, it has already taught us something valuable. That when we encounter the unknown, our response says more about us than about the phenomenon itself. If you found this analysis valuable, if you appreciate science done honestly without clickbait or sensationalism, I'd ask you to subscribe to this channel. We're building a community of people who want to understand the universe as it actually is, not as headlines want us to imagine. And I want to hear from you. What do you think about the Avi Loeb controversy? Is mainstream science too conservative, or is Loeb pushing too hard? Should we investigate potential techno-signatures on interstellar objects, or is that a waste of resources? Leave your thoughts in the comments. I read all of them, and the best discussions often happen there. If you want to dive deeper into the data, I've put links in the description to the peer-reviewed papers I referenced. The JWST spectroscopy paper, the Hubble observations, Loeb's statistical analysis, Wright's criticisms. Read them yourself. Don't take my word for it or anyone else's word. Look at the data and draw your own conclusions. 3. I, Atlas, came from the darkness between stars. It will return to that darkness. For a brief moment, it passed through our neighborhood, and in that moment, it challenged us to think carefully about how we respond to the unknown. That's the real gift it brought us. Not answers. Questions. Better questions.